Hey folks, I don't want to lose momentum on sine, cosine, tangent. So I made a really short assignment for section 6. This is going to be the last section that we do in chapter 4. The last two sections, 7 and 8, are really pre-calculus concepts. We don't need to do those in integrated 2. So we're postponing those two sections, 7 and 8, until we get into higher level math. You might do it at integrated 3, but we don't need to do it this year. So section 6 is going to really work on sine, cosine, tangent. It might also involve, just basic 30, 60, 90 triangle. So as I'm talking here, I hope you're setting up your notes. You don't have to copy all this down. This is example 1 in your textbook. So I'm going to go through example 1 in this video, and then we're going to try problem number 1 together. And then you're going to try to do 2 and 3, and then I'll show you how to do problem 4. This comes from example number 2 in the textbook, but it'll apply to problem number 4. So that'll be in a separate video. All right. So I love it when they give me the drawing, right? I don't have to set up any drawing, but it's not realistic for every single one of these problems. So I'm going to pretend like I don't have this drawing over here. And it says there's a kid flying a drone. He spots a drone at an angle of elevation of 30 degrees. So I would, make like a little stick figure over here. And if the kid was looking straight forward, that would be 0 degrees. But he's got to tilt his head up. He's got to tilt his head up to see the drone. So he's looking up at an angle of elevation of 30 degrees. That's why in the drawing they got 30 degrees right here. Okay. If let's say that the drone crashes and it's sitting down here on the ground, or like it fell down into a ditch or something like that, that would be an angle of depression going that way. So this is an angle of elevation, and going down like that is an angle of depression, which I'm going to talk about down here. So I'm not even going to write it down. In fact, I think I might just erase it because that's going to be in my second video. All right. So the drone is up here somewhere. So, I'd put a dot there for the drone, and then I would complete my triangle. Now it says, Rakeem, let's see, his drone's 102 feet above the ground. So I'm going to continue this down here and say this distance is 102. Sometimes they like to challenge us with this. It's not a big deal, right? If the kid's 6 feet tall, over here is 6 feet. Well, I'm going to take 6 feet off of the 102 and put 96 feet right in here. So I just did 102 minus 6. That gave me 96 feet. All right, so I've got 96 feet here. Now it says, how far is he from the drone? How far is he from drone? Okay, well, that's this distance right down here, x. That's the adjacent leg. This is the opposite leg. So 96 equals the opposite leg, okay? And x, the distance we're looking for, is the adjacent leg. So when I look at my rules on sine, cosine, tangent, right? Those are the three: sine, cosine, tangent. Those are the three that we want to practice. Tangent is the one that involves, tangent of an angle is the opposite over the adjacent leg. So that's what we got going on here, opposite over adjacent. So I'm going to do tangent of 30 degrees is equal to 96 all over x. These are the trickiest when x is in the denominator. So I'm going to show you what I would do. I would go 96 over x times x is equal to x times the tangent of 30. Okay, let me just kind of outline this here. And so now these x's over here divide out, right? So now I've got 96 is equal to x times the tangent of 30. The tangent of 30 is just something on our calculator, right? On Desmos. I'm going to divide by the tangent of 30 on both sides. And the tangent of 30 divides out here. And then now I'm on Desmos doing 96 divided by the tangent of 30 for my x value. So I want to jam over to Desmos here real quick. And I want to remind you of a couple things over here. All right. So You got to make sure right off the get-go that you change it to degree mode. It's always in radian modes when you open up a new Desmos, I think. I'm not sure why that is. Maybe you can change the preferences to fix that. And then in my problem, I'm doing 96 divided by the tangent of 30. So I want to go 96 divided by tangent of 30. And I get 166 point, and then we got to make sure we round to the right place. Let's see, what do they want? What do they want? To the nearest foot. Okay, so I'm going to go 166 there. So I go x is approximately 166. For those super advanced people, you might be saying, why is he not using 30, 60, 90 triangles? To go from the short leg to the long leg, you multiply by the square root of 3. So if you are super advanced and you're like, well, you don't need tangent, you just go 96 square root 3 and you got your answer. Hey, more power to you. Okay. But I want you to show that like you got 96 square root of 3 on the test. You'd want to show that kind of work. All right. Hey, like I said, I want to try a problem with you so that, you're like off to a good start. Love it. They got a drawing there. So this is, by the way, the angle of elevation right here. If the person on the boat is looking at the base of the cliff, that's 0 degrees right here. And then if you rotate up, that's our angle of elevation of 25 degrees. So on problem number 2, I think you got to make your own drawing. I'm just pointing that out so that you can make the drawing correctly. I would just start out with a right triangle on the first like 3 problems on homework, I think, and make it an angle of elevation right over there. All right. In this problem, we got 30 meters over here, and we want to know if this angle is 25 degrees, how big is side X down here? Well, I'm going to show it to you a little differently than I did in the example. I mean, in the example, I would have done this: 25 degrees equals 30 over X. For those super advanced people, this is 65 degrees up here. I could set up the tangent of 65, then it would be X over 30. The benefit here is all I need to do is multiply both sides by 30, and I've got the correct answer. Okay. Over on this one, when X is in the denominator, got to multiply both sides by X. I got to divide by the tangent of 25. It's like 2 steps. On this one, it's only 1 step. Okay. So you try it however you want. So I'll call this option 2. All right. Option 2. And this one over here is option 1. All right. Hey, thanks for watching video 1. Good luck on the homework for the first 3 problems. All right. Watch video 2 for the last 2 problems.